Welcome back to infyGyan, my dear friends. In this video, we have another very interesting question from radical mathematics. Here we have to evaluate fifth root of 10 plus 66 times square root 7 over 3 plus 4 over square root 3. So let's get started by considering expression equal to a first. Now I will simplify this radicand 7 over 3 plus 4 over square root 3. Now I will rationalize my denominator root 3. So I need to multiply here with root 3. So in the numerator, so I'll be writing 7 over 3 plus 4 root 3 over 3 or 7 plus 4 root 3 over 3. Now let's multiply numerator denominator by 3 again. So I can write my numerator 21 plus 12 root 3 and denominator will be 9. Now we will split 21 as 9 plus 12 plus 12 root 3 over 9. Now we can write 9 as 3 square, 12 as 2 square root 3 whole square plus 12 root 3. We can write 2 times 3 times 2 root 3 and denominator is 3 square. So our numerator is one algebraic identity a square plus b square plus 2ab, where a is 3, b is 2 root 3. So we can write 3 plus 2 root 3 whole square or over 3 the complete square. And this value I will apply here. So I can write a will be fifth root of 10 plus 66 square root of 3 plus 2 square root 3 over 3 whole square. Now square root and square will be over and we can cancel 66 by denominator 3 and it will be 22 in the numerator. So I can write 10 plus 22 times 3 plus 2 root 3. Fifth root of 10 plus 22 times 3 plus 2 square root 3. Or we can write fifth root of 10 plus 66 plus 44 root 3. Or I can write it will be fifth root of 76 plus 44 root 3. This is our A. Now raise power 5 both sides. Now fifth root and power 5 will be over. So I can write a power 5 will be 76 plus 44 root 3. Now a power 5 is greater than 1. Obviously 76 plus 44 root 3, it is greater than 1. So a will be greater than 1 for sure. Now I will consider a b power 5. It will be the conjugate of a power 5. So 76 minus 44 root 3. Let us add both the equations. So a power 5 plus b power 5, this will be equal to 152. And this equation we can say equation 1. Now from b power 5, I can say b power 5 is lying in the interval minus 1 and 0. So b will be in the interval negative 1 and 0. Two important conclusions, a greater than 1 and b should be in the interval negative 1 to 1. Now I will find product of these two. So let me write here a power 5 times b power 5. it will be 76 plus 44 root 3 times 76 minus 44 root 3. A plus b times a minus b. We can use difference of two squares identity. 76 square minus 44 root 3 square. Now 76 square is 5776 minus this square is 5808. Value will be negative 32, which further we can write negative 2 whole power 5. Left hand side it is ab whole power 5. After taking fifth root both sides and ab is real, then ab will be negative 2. Let us say this is our equation number 2. Equation 1 was a power 5 plus b power 5 equal to 152. These two equations are known now. Now I will use one algebraic formula. Let me write here a power 5 plus b power 5. It is equal to a square plus b square times a cube plus b cube minus a square b square a plus b. So we have to find out a square plus b square, a cube plus b cube. So let us consider a plus b equal to t. Condition on a was a is greater than 1. Condition on b was it is in the interval minus 1 and 0. So I can conclude a plus b will be greater than 0 for sure. So t must be positive. Now I will write two identities a square plus b square. It is equal to a plus b whole square minus 2ab. From equation 2, ab was negative 2. So I can write here t square minus 2 times negative 2. So a square plus b square, this will be equal to t square plus 4, which we will apply here. Now calculate a cube plus b cube also. So a cube plus b cube, it is equal to a plus b whole cube minus 3ab a plus b. So I will be writing here t cube minus 3 times minus 2 times t. Or I can write a cube plus b cube will be plus 6t. A cube plus b cube equal to t cube plus 6t. Let us apply to our a power 5 plus b power 5 equation. So I will be writing here a power 5 plus b power 5 once again. It is a square plus b square times a cube plus b cube minus a square b square times a plus b. So as per equation number 1, this was 152. Now these two values t square plus 4 and t cube plus 6t minus this is negative 2 whole square and a plus b was t. So I can write 152 equal to t power 5. 6t cube plus 4t cube, 10t cube, 24t, let me write here 24t minus 4t. Let us simplify RHS and write our equation as t power 5 plus 10t cube plus 24 minus 4 20t minus 152 equal to 0. Now this is one quintic equation. I will use rational root theorem. So let us find out eligible factors of 152. So I can write plus minus 1, plus minus 2, plus minus 4, plus minus 8, and so on. Leading coefficient is 1 only, so plus minus 1. Now I will check few values t equal to 1. If I will plug in 1 plus 10 plus 20 minus 152, will it satisfy? No, it won't. Let us apply t equal to 2. So 32 plus 10 times 8, 80, 20 times 2, 40, minus 152. Will it satisfy? Yes. T equal to 2 is our base solution. Now I can use synthetic division method. So let us write all the coefficients of quintic equation. So I will write SDM with base solution t equal to 2, and let us write all the coefficients of quintic equations. So 1, 0, 10, 0, 20 and negative 152. Leading coefficient as it is 1, 2 times 1, 2, addition will be 2, 2 times 2, 4, addition will be 14, 2 times 14, addition will be 28, 2 times 28, 56, 76, 2 times 76, 152, 0. So here we have coefficients for quadratic equation. Equation will be t power 4 plus 2t cube plus 14t square plus 28t plus 76 equal to 0. Our condition on t is t greater than 0. As per our quadratic equation, all of the coefficients or multipliers are positive. So from here we will be having only t negative. So on this ground, we will reject this quadratic equation for real solutions. Now t is greater than 0. So t will be 2 accepted value. So I will write here t equal to 2. T was our substitution. It was a plus b. Now our second equation was ab equal to negative 2. So we can think about one quadratic equation whose roots are a and b. Then this equation is sum of roots, and this equation is product of roots. So we can write quadratic equation as a square minus sum of roots, which is 2 here, times a plus product of roots. It is minus 2 equal to 0. This is one quadratic equation. I can use quadratic formula. So a will be equal to, I will write minus b. So 2 plus minus under the root b square. So I will write minus 2 square is 4, minus 4ac, 8 over 2a. So 2 plus minus square root 12 over 2, which further we can write 2 plus minus 2 square root 3 over 2, or I can write 1 plus minus square root 3. Now condition on a was a will be always positive, greater than 1, positive. So I will write here a equal to 1 plus root 3 and a equal to 1 minus root 3. Root 3 is 1.732. So this value will be negative. So we will reject 1 minus root 3. So I will be writing my final answer a equal to root 3 plus 1. I hope friends you will like this video. Thank you so much for watching. Do not forget to like, share and subscribe. Bye bye till next video. Good luck. Take care of yourself. Bye bye.